tonight we're going to talk about shooting stars and meteor showers. Shooting stars are not really stars. They're little bits of pebble size material, dust size, sometimes larger, that comes into our atmosphere. But people didn't used to know that, so they referred to them as shooting stars. And the reason I decided to do this presentation tonight is because November 17th this year, which is a Friday, I believe, moving into a Saturday, the 18th, which means a lot of us don't have to get up and go to work the next morning. We'll have, hopefully, clear skies and a nice meteor shower. So late the night of November 17th, like approaching midnight, till early morning hours of the 18th, maybe sunrise, hopefully we'll be able to go outside and see up to 20 meteors an hour. But don't hold your breath. Meteor showers are unpredictable. This year we will not have a moon to interfere with our meteor shower. A lot of times there's a good shower and the skies are clear, but we have a nearly full moon, and so it's hard to see. If you can get away from city lights, you may see more, but for the brighter meteors, you only need to lean back, so pull out a comfortable chair or put a blanket on the ground, just lean back and enjoy the show. But let's talk a little about what these shooting stars are. First of all, in our solar system, when it formed, there were 4 inter-terrestrial planets that formed. But outside of Mars, where there probably should have been another planet, Jupiter's gravity kept disrupting any planet that tried to form there. So it's not a planet that exploded that caused the asteroid belt. It's the fact that something was trying to pull together a planetoid, and Jupiter would come by with its gravity and pull everything back apart. Plus there were debris fields left over from asteroids colliding with each other. And the asteroid field is a lot less dense than it used to be. It's been pulverized, some have been ejected. Mars, we think, captured a couple of asteroids that it now, that we call moons of Mars now. And so there is this big field of rock and metal between Jupiter and Mars. Now, meteoritics is a study of extraterrestrial material. It would have been called meteorology, but they thought that comets and meteors, shooting stars, things like that, were actually something atmospheric in Earth's atmosphere. They used to call rocks that fell to the ground thunderstones. They thought maybe they were shot out of the top of a volcano, or that lightning hit the ground and these were fused melted rocks that went up into the air and fell back to Earth. So meteorology actually has to do with our atmosphere, and it took a while before it was understood that these rocks falling from the sky and comets and shooting stars were not from Earth's atmosphere. They were not part of our meteorology. So those that work with meteoritics actually need to know about astronomy, chemistry, geology, a lot of things, and pull it together. One of the people that I know here on campus that works with meteorites is actually over in the chemistry department. And because of her chemistry background, she spent several summers at the Smithsonian testing meteorites to see if they actually are or if they're meteorons. And if they're meteorites, she categorizes them as to what type it is. But she's a chemist, not a geologist, not an astronomer. Now, it was a German physicist, Klunding, back in 1794, that first proposed that these rocks falling from the sky were from space, not from Earth. Well, he was kind of laughed at. Nobody took him really seriously. But then in the late 1790s, in Italy and in England, there were major rock falls from the sky that numerous people witnessed. Now, the Academy of Science laughed at these people. They said, well, you're uneducated. We're scientists. You guys don't really know what's going on. You can barely read. So what do you know? And they dismissed it. But there were some scientists that took them seriously, went out and started picking up lots of rocks. And when they tested them, they found, these rocks aren't made of the same stuff that most Earth rocks are. And there's some weird metal mixes here. So we'll come back to that in a moment. But finally, they were able to establish that, no, these rocks have very little to do with Earth other than they're falling to the surface. So through chemical analysis, we got the science of meteoritics. Okay, official terminology. A meteoroid is a chunk of material from space. It can be dust size, a lot of them are, pebble size, maybe up to the size of a boulder. If this meteoroid enters Earth's atmosphere, then it's going to experience friction with Earth's atmosphere, and it's going to heat up, and it's going to form a plasma trail that glows. And so really the meteor is the trail that we see that's bright and glowing. It's not the actual pebble or dust grain that's coming through the atmosphere. But if it's big enough, like the size of a Mack truck, maybe the size of a big refrigerator, but it's got to start off in our atmosphere as something big, and then as it goes through the air, it's going to sublimate, that is, it's going to heat up, and this outer layer is going to burn off. And then, if it's big enough to make it to Earth's surface, we call it a meteorite. And then most of those that people take to Tammy over in the chemistry department are the meteorons. She gets a lot of those. I've taken one to her myself. So if it survives passage through our atmosphere, it's a meteorite. There are three main kinds of meteorites. The irons, and here's where the chemistry got interesting. Most of the time on Earth, wherever there's a lot of iron found, there's not much nickel. The two don't mix in Earth's surface material. But when meteorites fall to Earth and are seen, so they're known meteorites, and they're metallic, when they test them, they're mostly iron, but there's a maybe 7 to 10% mix-in of nickel. It's an alloy, and that's very different from Earth rocks. Plus, if they slice them open, they can see where the crystals have intertwined in a way that we do not see on Earth. It has to happen in low gravity. Then there are also the stones. Well, now the stones do look a lot like Earth rocks, so if you just happen across one of those, you're probably not going to recognize it as a meteorite. It looks like an Earth rock. The irons look different. If you pick them up, they feel different. And then there are also what we call the stony irons. A good example of the pallasites, which are beautiful, beautiful meteorites. So here we start off with the asteroid belt. And notice that there are some asteroids that cross Earth's orbit, but those aren't the ones that typically cause shooting stars or meteor showers. Those are the ones that cause us to panic and wonder, how can we prevent an asteroid from hitting Earth? That's not really what I'm talking about, but I do want to point out that most of the meteorites come from this area. When asteroids first were pulling together, they were large enough and hot enough that they differentiated. This means that light material was rising to the surface, and the heavier material, the metals, were sinking into the center. And so what we got was this kind of area on the surface that's mostly silicate, rock-like material. In the core, we have that nickel-iron mix. Again, a small amount of nickel, a lot of iron. But asteroids cooled off pretty slowly because they're really not that big. The largest one's not as big as our moon. And so as they cooled, there'd be an area where the lighter material was trying to rise, the heavier, denser material was trying to sink, and as it cooled, it got stuck together. So you have this gray area here in the center that is actually a mixture of the rock and the metal. If an asteroid collides with something else, a lot of times only the surface gets knocked off. And that material, if it makes it all the way to Earth and happens to enter Earth's atmosphere, that would be what would cause our rocky or stony meteorites. But if it was a heck of a collision and the asteroids actually cracked all the way open and pulverized the outside, you could get pieces of the inner core, the metallic part, and the mixed area, the stony iron mix, and those could actually survive and make it to Earth. So here on the left we have an iron meteorite. It's got this very telltale sign of these thumbprint indentions all over the surface. On the right and down at the bottom on the side, your right side, my left side, those are pallasites. This is from that area that's mixed. These are sliced very thin and they're backlit. And so what you see is that primarily iron metal, and in it is olivine. It's the same as the August birthstone peridot. And it looks like stained glass windows if you get it sliced thin enough, with the metal holding beautiful, colorful, translucent, not transparent rocks. And they're just gorgeous. Now, down on the lower left, we have what's called a chondrite. And what we have here are round areas, the chondrules. And this was the stuff that pulled together small bits at first, and then as these pieces would plow into each other, they'd heat up and kind of weld together. But then eventually, these objects would be large enough to have enough gravity to start pulling more stuff in. So it never could pull together like a planet. But we had all these rocks running around out there with things that were melding themselves together. This, on the lower left, did not get hot enough to melt all the way through. So we see the original small pieces. The bigger asteroids would actually differentiate because they were hot enough where everything melted and the lighter material again rose to the surface, the heavier material sank. So if we get something from that, we do not see these chondrules. To the left on the top, I want you to notice how dark that is. On the right, notice you can see the fusion crust, the crust that heated up as it came through the atmosphere, and it's dark. Even in that center area, you can see with the chondrules there, look at the surface on the bottom part. And here, you can see the part that's not sliced. Look how dark that is. Most asteroids are dark. Then they're small. So if they're out there and they're dark and small, how do we see them? Well, asteroids were not discovered until the early 1800s. And then we only knew of a few of them. But there are lots out there. On the upper left, we have a photo of rocks. These are not asteroids, but they're good examples. And they are warm. But against the cool background, in visible light that our eyes see, we don't really see the one on the right, even though it's bigger. But in space, these asteroids absorb energy from the sun. They're heated up. They're warmer than the cold background of space. So if we look in the infrared, notice how bright that one on the right is glowing. That's glowing in infrared heat from the sun, and infrared cameras can detect those. So in infrared, we can see a lot of asteroids out there. Now, with all these asteroids, you'd think, well, maybe instead of just running into each other, they'll also run into other things. And we have a lot of evidence of that. Mercury's to the left, very cratered. We have a close-up of Mars' southern highlands. You can see all the craters there. Our moon shows a history of lots of impacts. The most cratered body in our solar system is Callisto, the outermost large moon of Jupiter. This one I find really interesting. On the lower left, we have from 1994, I believe it is, comet Shoemaker-Levy 9, which when it got close to Jupiter was just shredded. It was pulled apart. And so there were 21 pieces of it that spread out into space, and it looked like a pearl necklace is what people described it as. And then it plowed into Jupiter. Well, this is Ganymede, Jupiter's largest moon. And notice how those craters are just one right after the other. And it's possible that a comet that was pulled apart by Jupiter's gravity is what plowed in there, and it just, one right after the other, leaving these craters. Now, Ganymede's got its own pretty good gravitational pull. It's larger than the planet Mercury. And Jupiter's big gravitational pull will pull stuff towards it. There's Ganymede. It's a big target sitting out there. So it's kind of a sitting duck along with Callisto for things to plow into. This is one of my favorites. This is a mid-sized moon of Saturn, Mimas. It's called the Cyclops of the solar system, otherwise, to my mind, known as. Does anybody else see the resemblance? Surely he had that in mind. But anyway, we look out into our solar system and we see all these craters. Well, if other things got hit, shouldn't Earth have been hit also? It was, and we have evidence. On the right is the Barringer meteor crater in Arizona. It's about a mile across, and it was formed by a metallic meteorite. My husband got me a rock one year for, I think it was our anniversary. Yeah, I was telling people, yeah, my husband got me a rock, big rock. But it's not the kind I wear in my hand, it's a piece of that meteorite. But meteorites can impact Earth anywhere. Now, this is a big metallic meteorite. It's an iron. It's in Africa. Now, don't think that the impact carved out this. No, they terraced it to make it safe for visitors to come see. But as you can tell, it is a huge meteorite. And here you still see the thumbprints, the indentions where it fell through space. This is not an Earth rock. This is something that came from space. But it wasn't large enough to form an explosive impact crater. The Barringer crater and others around our planet, these are not just gouged out holes in the ground. This is where a large meteorite has impacted the surface and then it explodes. So these are explosive craters. And right there is the largest remnant of the meteorite that formed this impact crater in Arizona. Now, that's impressive. Has anyone here ever been there to see it in person? How impressive is this? Big hole in the ground? So people are impressed with this. But guess what? There are other impact craters that people don't know about. Now, there are finds which were not witnessed, and there are falls which were seen. But here's one of the amazing ones. This is the Peekskill meteorite. That's a big shooting star, people would have called it. It came in on a Friday evening in the fall of 1992, and this is when video cameras were becoming popular. And there are lots of parents out taking videos of their sons playing football, because this was high school football time as it came across, and it was so bright that the light was casting shadows, and people were turning around with their cameras going, "What is that?" They had so many images and videos of this meteorite coming in that they were able to put this information together, kind of triangulation, and determine what its trajectory had been, what its path around Earth had been in the solar system before it ran into Earth. Now, it happened to land on a teenager's car. She came outside after hearing a large bang and went, "What happened to my car?" Well, you see the meteorite next to it. And what you also see is where the fusion crust has been knocked off. And this is a picture of it. You can see the red paint from the car. So of course she did what everyone does when their car is damaged. She contacted her insurance company and said, "My car is damaged. I need for you to fix it." They go, "What happened?" A rock hit it. What kind of rock? Well, you know, one from space. Sorry, that's an act of God, and we don't cover acts of God. However, there are crazy people that like to buy meteorites. And if you can buy the car that it hit and has the paint, you're even happier. She got a lot more money from a meteorite car collector than she would have ever gotten from the insurance company. Got her new car and she was happy, and so was the meteorite collector. I only know of 2 people that have ever even been hit by meteorites, not personally, but I know of. I don't know of anyone that's been killed. The only living creature I've ever been able to find in the historical records that was killed by a meteorite was a dog in 1911 in Egypt. It came down and actually hit him directly on the head. He was gone before he hit the ground. There was a child that was hit on the hand or arm, but it was by a little bitty rock, no damage. Ann Hodges was a different story. On a Sunday afternoon after church, they went out and had a big lunch. She went home, decided to take a nap on the couch in her living room. She woke up when something hit her on her thigh, and I don't have the picture here, but there's an actual photograph, you can see it online, of a doctor showing this bruise that's like this long on her side. Well, when she was hit, obviously it hurt, she woke up and went, "Those doggone kids outside, they threw a rock through my window. I'm going to get them this time." Charged out the door to find the kids. No kids. But she did happen to turn and look at her house. No broken windows, but there was a big hole in the roof. She went back inside, and there was the rock on the floor, and she noticed there was also a hole in the ceiling of the living room. Went upstairs. There's not only a hole in the ceiling upstairs in the bedroom, apparently this thing came in and bounced off a chest of drawers before it went through the floor, ceiling, bounced off something before it ricocheted and hit her. Imagine what it would have done to her if there hadn't been all these ceilings and floors and walls and pieces of furniture that it lost energy hitting before it got to her. Well, here is a picture of the hole in her ceiling. And of course, they called in the officials. If you have a meteorite hit, don't you call the police? But anyway, they came, and the owner of the house, of course, heard all the news about this. It turns out they were renting the house. And even though she was the one hit by the meteorite, when the owner of the house took them to court saying it was his rock, not hers, the court sided with him. He was the owner of the property. The rock landed on his property. It was his. However, when the Alabama Museum of Natural History at the University of Alabama in Tuscaloosa bought it, they decided since she was the one that got hit, they would name it for her. So it's the Hodges meteorite, and you can actually see it displayed in the Museum of Natural History next to the library in Tuscaloosa. Now, there have been some big impacts. That was not a big impact, but there are more than 170 known impact structures on Earth, and I do want to point out that the southeastern U.S. seems to be a place meteorites like to land. Here's where 2 of them landed a long time ago. Tennessee. You're impressed with the Barringer meteor crater, the one in the upper left, Wells Creek? It's 8 times bigger. Flynn Creek to the right, it's twice as large. Never heard of them? No, Tennessee, unlike Arizona, is hilly, not flat, and we have all this green stuff and trees and so on that grows. And so unless you're actually standing in the middle of Wells Creek on that central hill, looking around and seeing that there are a bunch of hills, but they're all circling you, you don't realize anything strange is going on. So these are very old, highly eroded, and just not very obvious. They used to be, but they're not now. Well, what about other shooting stars? You know, like the ones that you just see in the sky, but don't actually make it to Earth. Well, those could be from asteroids originally or comets. These could be pieces of asteroids that were knocked off, that were small and made it to the surface and burned up. But usually the meteor showers come from comets. And this is just an example of a meteor shower. I've forgotten what year, 2002. And notice there are lots of lines. Again, these meteors are the plasma trails in our atmosphere. You can occasionally have a shooting star by itself. These could be either of asteroid or comet origin. This was taken at Sunset Crater National Monument in Arizona. It's moving around 60 kilometers per second. And the reason it's greenish here is it's energizing the atoms of oxygen in our atmosphere, and they're emitting green light. This is at a very high altitude. This did not survive to hit the surface of the Earth. But it's one of those bright attention getters. So how does a comet do this? Well, the typical orbit of a comet is very lopsided. They're elongated, cigar-shaped almost, and they start way out in the Oort cloud, maybe the Kuiper belt of our solar system out beyond Pluto. They're cold. They're chunks of ice and rock. Some people call them dirty snowballs. I tend to think of them more as snowy dirt balls. They're held together by ice, but there's a lot of stuff in there, but it's small. It's not big chunks of rock and metal. As a comet comes in its orbit to the inner solar system, about the time it starts reaching, say, Saturn, it's heating up enough to start sublimating, again, melting without going through the liquid phase. And so as these different ices are sublimating, they're releasing pebbles-sized material, dust, and so it's being spread out in the comet's orbit. It doesn't happen far out in the solar system, about the time you get to Saturn. But as it comes in closer to the sun, it's releasing more and more of this material. Comes in close to the sun, and it's releasing even more material. And remember, Earth is close to the sun compared to a lot of the solar system. And so as it keeps going in its orbit, especially if it's a periodic comet, every time it comes by, it's releasing more of this material. And so you have this built-up debris field. And then if this debris field happens to be along the path of Earth's orbit around the sun, 1 or 2 times a year, Earth will plow through it. And so when we do, we see lots of these meteors in the sky in an evening or spread out over several days. And this is what constitutes a meteor shower. I only know of one meteor shower that is not due to a comet. It's due to an asteroid, but everything else I think is due to comets. There are 2 really good meteor showers that are pretty reliable. Some years are a lot better than others. The Perseids and the Leonids. Those are the ones that are, whoops, let's see. Yeah, they also have the Geminids highlighted in December. I haven't had as good of experience with those, but in August, the Perseids are pretty reliable. In November, the Leonids are reliable. So those are good ones to watch for. And around the 17th to 18th of this month, we should be able to, if the skies are clear, see a good show by the Leonids. Now, they're not exactly on the same day every year. It can vary. Depends on how long it's been since a comet came through the area, other variables. So I can say the Perseids peak in mid-August. I'm not going to tell you a specific date, but mid-August somewhere. Now, the comet that forms the shower known as the Leonids, well, it comes by about every 33 years and releases new material. And so there have been some spectacular meteor storms, not just showers, but storms caused by Comet Tempel-Tuttle every orbit. Now, why do we call them the Leonids or the Perseids? Well, this is showing the radiant, and what that is the point in the sky from which all these different meteors seem to come. They're not coming from that actual one point in the sky. We're plowing into a debris field, but they're coming parallel as we turn into them, and it's just like railroad tracks. They're actually parallel, but from our perspective, it looks like they're moving to one point in the distance. The same way all these meteors coming in parallel into our atmosphere, you look back and there seems to be a radiant point from which they're all originating, and we give it the name of whatever constellation it happens to be in. So if it looks like the point of origin is in Leo the lion, we'll call them the Leonids. The unfortunate thing about meteor showers is, think about Earth going around the sun, rotating on its axis. When you're driving on a long trip, have you ever run into a cloud of bugs? And they get all over your windshield? Your back windshield, right? No. Yeah, it's clear. Why? Because you're plowing into them. So it's the front windshield that gets all the bugs splattered all of it. The same way, before midnight, we're on the trailing side of Earth. And so it's hard. Occasionally we can have an individual meteor catch up with us and plow into our atmosphere. But for these showers, we're having to turn into the debris field, which means it's after midnight or after 11 o'clock at night when you'll start really seeing them. And they can go on until daybreak. So the unfortunate thing, and the reason I was going to recommend you might give these a try, is because it's happening on a weekend evening instead of a evening when we all have to get up and go to work the next morning. Now, the Perseids seem to come from the constellation Perseus. To me, Leo actually looks like a gigantic cat sitting down on its haunches with his front legs stretched out in front. Perseus, he's supposed to be the hero that, rescued Andromeda. I've never been quite able to make that one out. It's harder to see. But there's the double cluster in Perseus, and so it's interesting to pull out a telescope or binoculars and take a look at the double cluster while you're waiting for these Perseid meteors to come by. And I do want to point out something. This is a Perseid meteor shower. These photographs were taken over a 4-hour period. It's composite, it's wide angle, and this was taken on the Canary Islands where it's dark. But this is not what you would look up and see in a minute. This is 4.5 hours. And you see the telescopes there in the foreground, but the camera was tracking with the rotation of Earth on its axis. So over, you can count how many are up there. And this is what you're seeing in a shower, a regular shower, over 4 hours. So if you go out and you're looking at a meteor shower, don't expect the sky to look like it's on fire. This is another image of the Perseids. This is 2015 at Mount Rainier National Park. And again, it's a longer exposure. This was not taken in a second. But with that long exposure, you can also see the Milky Way in the background. It almost looks like it's coming up out of the mountain. And you see one that got really brought up here again with that greenish glow to it. Now, has anyone ever seen the license plate from Alabama, Stars Fell in Alabama? When that came out, I got curious and I looked it up. I wanted to know what these stars were. I was thinking, stars, okay, Tennessee has country music stars. I'm not sure what it is Alabama has. Well, it turned out it was from an 1833 Leonid meteor storm. This storm, and it was a storm, not a shower, was seen all over the eastern U.S. People on ships in the Gulf of Mexico noticed it. People along the eastern seaboard knew about it. The Sioux Indians out in the west mentioned it in their archives. There was a young Abraham Lincoln that was living in, I believe, I won't say that, I'm not sure the city. But anyway, he had moved in recently and was trying to get started as a lawyer. And since he didn't have much money, he was renting a room from a deacon of the local Presbyterian church. And a few weeks after he came in and settled in, the deacon was pounding on the doors of all the rooms that he was renting out, saying, "The day of judgment's come, it's the end of the world." And he was pounding on the doors. This woke up Abraham Lincoln. And he said, "What is going on?" Went outside with everybody else, and people were running around, church bells were ringing. He thought, is there a war starting? What's happening? And they were going, no, it's doing what the Bible said. The stars are all falling to earth. It's the end of the world. Do you know people were confessing to each other wrongs they had done to each other? There was a lot of that going on. But this young lawyer kept his cool. He looked up in the sky. He studied the background constellations and was quoted later as saying, the constellations were there. Those stars were not falling to earth. So he concluded that not all of the stars were falling to earth. It was a meteor storm. And so he told the deacon he needed a good night's sleep and went back to bed. Amazing. Frederick Douglass, in his biography, wrote, "I witnessed this gorgeous spectacle, was awestruck. The air seemed filled with bright descending messengers from the sky." Now, there was a scientist watching this too, though. His name was Olmsted, and he not only watched this, he's the one that determined the radiant. It's by a particular star, Algeiba, I think, Algeiba. John, do you know how to pronounce that one? Algeiba. However, if anyone here speaks Arabic, no? A little bit? Algeiba. Okay, I see it all the time, but I'm not quite sure how it's correctly pronounced. Anyway, it seemed to come from very near that star. He was being calm and watching this, and he had grad students helping him watch this. But not only that, he took newspaper accounts over the next few days and collected them. He interviewed other witnesses. He corresponded with people in other parts of the U.S. and pulled together a body of literature, firsthand witnesses, and pulled it together. And it was probably his account and his gathering of information that finally pulled this together and showed this is science. This is not superstition. This is not folklore. This is not mythology. There's actually something coming into our atmosphere, and we can name it for what it is: material burning up in our atmosphere. Now, that was 1833, the night the stars fell, the night the sky was on fire. Olmsted and others working with him predicted that this was from the comet that would make another pass by in 33 years. He didn't live to see it, but in 1866, they had another meteor storm. I don't remember the 1966 Leonid storm, but I did have a professor when I was an undergraduate that actually saw it. At the time, he was a grad student, and he had gotten to the place where it was predicted to be spectacular, but he was running late. He was trying to drive out to a dark sky spot. But then looking through his windshield, he started noticing some meteors and thought, oh, I just might as well pull over and take a look. And when he got out, he said within a few minutes his jaw dropped, that there were so many meteors coming down in the sky that he just stood there, even though it was not in a dark sky sight, and just stared. It didn't last long, maybe 15 minutes, but he said he had had, the experience of a lifetime seeing a Leonid meteor storm. It repeated again in 1999, not as strong a storm, but here they were seeing several thousand meteors per minute, not a number you can count in 4 hours. That's the difference in a shower and a storm. So the best ones to look for are these, but again, I'm going to suggest go out and try the Leonids. Next summer, give the Perseids a try. Those tend to be, in my opinion, the most reliable ones. And Also, while you're out there, just take a look at other things in the night sky and just enjoy it. Do not try to use binoculars, telescopes. Just lean back, have something warm to drink, and friends or family with you, and enjoy it. So, thank you. Any questions? I'm sorry? Oh, no, this was a short. Yeah. This was short. Yes?
What do you think the next leading storm will be?
Add 33 years to 1999. 2032. Now, it's not guaranteed because 33 years after in 1899, there was not a big storm. It was good, but it was not anything like 1833. So it's not guaranteed. The closer we get to 2032, the more we'll be able to determine how we're going to hit that comet debris field.
So I think the last one I saw 500 to 800 meters an hour. The last one went.
Did you?
Yeah. So it was pretty low. That's the best thing I've ever seen. So.
The last 2 years, I've gotten up for the Perseids in the morning and just gone out in my backyard and looked up, and after 10 minutes, I've seen 5 or more. I said, okay, I've seen it, and go back to bed. So it's pretty reliable, but I've not seen that many. Yeah. What you think you're going to see, yes, but don't expect that every year. Other questions?
How wide of an area on the surface is it covering?
Well, for the 1833 meteor storm, it was seen from.
Do you have to be in a specific region of the country to be able
Well, that's what I was going to say. It was so great that it was seen over beyond the Midwestern U.S. and on the Atlantic seaboard, but in Europe it was nothing spectacular. So there are regions that will have much better views than others, and I can't tell you right now what the next ones will be, but there are areas when it's past midnight, it's dark, it's turning in, and you happen to hit a denser area of the debris field that you're going to have a better shower. So yeah, there are regions that are going to have better than others, and I'm not sure how to predict that. So.